comparing one and two variable data. Okay? So the first thing I want to do here is we want to think of the types of graphs that we've been using in the past, and then we're going to try to put them in a category. Which graph represents which type of data best? If you look in your textbook, it might help you out along with this. But who has a suggestion of a type of graph they've seen before?
Oh, pie graph.
Pie graph? Okay, pie graph is a great one. How much data can be represented in a pie graph? It's a one variable data, a pie graph. Okay? So pie graph falls under here. We focus on one data and we give percentages with pie graphs, right? We're not comparing two different ones. Any other ones? Scatterplot. A scatterplot. Now some of you guys maybe not have heard of a scatterplot before. Scatterplot, anyone who knows about it, what type of data can we use that to represent? Two variable. In scatterplot, we are representing two pieces of data and we're comparing them to each other. So a scatterplot falls under, that's very loud saying, falls under two variable data. Thank you, Roy. Bar graph, okay. How many pieces of data do we represent with a bar graph?
One.
There's many people in it, but we're usually only comparing one type of data. Maybe it's heights, right? How tall people are, or how old they are. It's usually one piece of data with a bar graph. Now there are other types of bar graphs that do represent more than one variable of data, but for the most part we're used to using bar graphs with one variable data. Whoops. Any other ones?
Chart graph.
Chart graph. And what is a chart graph?
Chart.
Okay. And how can you represent it with a chart? How many pieces of data can you represent with a chart? You can represent as many types of data as you want. So for example, if you're not quite sure what he means by a chart graph, right? Let's say we had a name, somebody's name, and we could put age involved. That could be one part of the chart. There could be other parts, weight, height. We can represent many, many pieces of data with the chart. So a chart can technically fall under both. It probably helps us look at two variable data better. Okay, so we're going to put chart. What did you say, a chart graph?
Yeah.
I'm just going to say a chart.
Yes, chart.
It's not really a graph. We could say a chart would fall under two variable data. Any other ones you guys have seen before? Pictograph. Anyone remember what that looks like? Use pictures in it. What is it very similar to? It's very similar to a paragraph, okay? So we'll put it in here. I don't even know if I can spell it right. Pictograph, is that right? That's supposed to be a T. Very similar to a bar graph, you're right. Any other ones? There's at least one more I want to talk about. Yes, histogram. I do want to talk about a histogram. Anybody know what histograms represent? They look very similar to something. Anyone know what histograms look similar to? No, those are Venn diagrams. You're right, those are good, but we're not going to talk about those. They don't help us too much in these. Histogram pretty much looks like a bar graph, so I'm going to just roughly sketch one here. But there's one major difference with a histogram and a bar graph. The name is very different, yes. And a bar graph can have spaces, but it doesn't technically matter. We could represent the bar graph this way. And we're going to call these numbers on the side 1, 2, 3, 4. What's very important is what's on the bottom, comparing a bar graph and a histogram. Now, histogram is one variable too. Okay, so I'm going to put that under there. A histogram actually deals with ranges. What our bar graph might do with someone's name, maybe we have Bob, okay, maybe we have Mike, Sam, sure. We have one person underneath. Each bar represents one person or one object, where a histogram, okay, will usually represent a range, okay? So it could be like time, from 0 to 5. How many people fell in this category? And they'll give you a title. Let's say it was running.
That's a bar graph.
10K. Nope, I'll show you how this can work. Running 10K. One person took 0 to 5, and this will be our minutes. Okay? Which is very unrealistic, but that's fine. We had 2.5 people that clearly drove. Took 5 to 10 minutes. Okay? 10 to 15. So a histogram represents a range of data. Because maybe what will happen... Oh, that did that again. Wow. That's okay. Huh. It's okay, I'll just erase it. Not sure why that happened, sorry. And the reason we use a histogram in comparison to a bar graph is because what you're going to find is if I actually took everybody's individual running and there were 300 people in this race, I'd have an extremely large bar graph. There'd be 300 bars along this, really hard to compare people. Maybe I just want to get groups of people. I want to know how many people fell in the 0 to 5 range, the 5 to 10 range, the 10 to 15, 15 to 20 range. And that gives us a better idea of groupings. Okay, histograms help us with groups. Now, we're not just specifically focusing on histograms. I did want to talk about that because I know that's not usually spoken about too much. Okay, so I'm going to take that off. What we're really going to focus on is just 1 and 2 variable data. So we've gotten 4 in one and 2 in the other. I'm good with that. What we're going to look at is some data now. Okay, so I've put some data on the next page. We went over to Champions League, and these are the top scorers. Okay. Is it scorers? With an I? I guess it is. Yeah. Scorers. In Champions League right now. So, I didn't get the titles. This is goals. Okay. This is penalties. This one here is unknown. Really what I'm looking at is I want to talk about this one here also. Offsides. Okay. So, penalties, goals, and offsides. So, let's say I was representing goals. If I wanted to represent goals of each of these players, I think we have about 14 of them, something like that. Would I be representing one variable or would I be representing 2 variables?
2 variables.
What would they be?
It would be the goals and the offside.
Okay, I wasn't talking about offsides yet. You're right if I was representing both. But if I have the guy's name and their goals, how many variables are involved? There's only one variable involved. Their name isn't technically a variable. Their name is who they are, and we're testing how many goals they're getting. So, let's say we were to create a quick chart on the other side. We have 2 guys at 8, 7, 5. Actually, you know what I'll do? I'll zoom out on this page. See if we can make a quick graph here. We'll try to make a quick bar graph. Okay. BYCR. I'm just going to use letters. Okay. So we have BY, CR, LM, EL, and O. Something in O. What did I say in between? E, L. And we'll put goals on the side. These will go up by 2, 4, 6, and 8. Okay. So, we have one variable here, goals. And the first 2 guys have 8, one guy with 7, 2 more with 5. So if we were to create a bar graph, we have 1, 2 guys with 8. I really should be using straight lines. I don't know why I'm choosing not to. Here we go. Okay. So we have 2 guys who have 8 goals. I know this is very easy to the rest of you, but we're going to take this somewhere. 7 falls in between 6 and 8. And 2 other guys had 5. 5 falls between 4 and 6. Okay. If I was to represent offsides on the same chart, would it be very easy to read this chart? If all of a sudden go up to 14s and I stacked another bar right through everything, would I be able to differentiate between the 2? So for instance, I take this and then I extend it up to maybe 14. This guy over here, the second guy had 5. Second guy had 5. 2, 6, 1, and 4. 2, 6. Oh, was he? 5 and 4, was it?
No, it's 6 now, but previously it was not 5 goals.
Oh, it's supposed to fall right in between. It's supposed to be 5. You're right, it isn't the greatest graph. I'm looking at 6. Yeah, 6, and the other guy I think was 1. Okay, so when we're looking at this, is this a great representation of two pieces of data? Not really. What are some things I could have done, Trey? Yeah, maybe changing the colors. So let's say I change the color here. So instead I used offsides, I put a red line here. Okay? Oh, you're right, that was goals. I'm already getting confused trying to set this up. So I used red for goals, let's say, instead. Am I able to differentiate between the two?
Yeah.
I would still say this is a very hard chart to read. And the reason being, how do I know that this isn't just added on top and I'm supposed to do some type of subtraction? Maybe this is 14, subtract 8, so this range here is 6. Or is it representing all the way to the top? I need a pretty long explanation with this graph. So a bar graph wouldn't be the best way to represent these two pieces of data. Okay, you can have stacked bar graphs, and that's what they are. They're actually adding and subtracting on top. Okay, but this one would become relatively difficult to work with. Okay, we saw when we put just goals, it was pretty easy to read, but as soon as you put a second piece of data in here, it became relatively difficult. Okay, let's do a comparison of goals and offsides. So I'm just going to write these numbers beside. 14, 5, 2, 6, 1. 14, 5, 2, 6, 1. We're going to try to create a scatter plot. Okay. So when we're creating a scatter plot, we're going to have a vertical and horizontal axis. And technically, it doesn't matter which variable we put on which axis, except that one of them usually causes another. Now, in this one, we've kind of taken two random ones. A lot of times when we make these, we have an independent, if you guys remember, and a dependent variable. Okay. Now, we're looking at these, and if you're going to have to know soccer a little to answer this type of question. But goals and offsides, does one of them cause the other?
Not really. If you're offside, you can't.
Yeah. So if I'm offside, I can't get a goal. Okay. But if I do get a goal, does that create an offside or take one away? It just makes it worse, right? So these aren't really related pieces of data, but what we're going to try to find out is if there's a relationship between them. Scatter plots will help us find relationships. Some of them would be very easy. Something like shots and goals would be a very simple one to see a correlation between. You have to shoot in order to get a goal. Yeah, that's an interesting stat. So let's try to plot this together. We don't technically have independent. We're going to see if there's any type of relationship. So we have goals. We'll put goals there and offsides on the bottom. Now goals went up to at least 8. So let's put 2, 4, 6, 8. And offsides went up to 14, 2. Okay, so we have 2, 4, 6, 8. This should be 10. 2, 4, 6, 8, 10, 12, 14, and 16. Okay, so what we're going to need is probably a legend on the side. For instance, BY had 8 goals and 14 offsides. So I'm going to use a specific color. I guess I'll use black. BY will be done in black. Okay, that will be my point. So that will be my first point. And this is kind of like a bingo chart when setting it up. This person had 8 goals, so I go up to 8, and 14 assists. I go across to 14. So he would fall here on a scatter plot. The next guy was our CR. He had 8 goals and 5 offsides, right? So number 2, CR. 8 goals, but 5 offsides. Puts him here on the chart. The next guy, LM, I'm just going to double check, was 7 and 2. 7 goals, so that's one other, but only 2 offsides. He falls here on the chart. EL, 5 and 6, and then 5 and 1. So EL, 5 and 6. and then it was just O for 5, and that was 5 and 1. Okay. Oh, I forgot to write a number in there. What color did I use?
Put him at 7.
Oh, I did? Great. He was 5 and 1. Did I put the other guys at 7 too? They're not supposed to be, are they? One of them was supposed to be at 5.
No.
Green guy was. Purple guy was alright. Bacon is here. And 5 and, what do you say? Better check. EL. 4 is 5 and 6. 5 goals and 6 offsides. Okay. Purple, that's right. Okay, so we've kind of set up our scatter plot. It's tough to see if there is a relationship, and we're going to get into that a little bit later, okay? But we can make some observations just to start. The guy, or one of the guys with the most goals, had a lot of what? Offsides. Another guy, these guys, though they're not in the same area of the chart, he's very far to the right and towards the top, and you'd say that this guy, CR, is to the left of the chart towards the top. They both actually had the same what? Goals, okay? But offsides was very different. This guy had far fewer offsides than this guy did, okay? These three are almost in the same range, where this one's kind of far to the right. So they're different in terms of where they fall. It looks like these 3 or 4 had fewer offsides, you could say 5 or 6 or less, and their goals are roughly the same. We have a guy down here who's a bit lower, and this guy's higher. So just looking around a scatter plot, you have to realize how to compare them. Even though they're not in the same range, there still may be similarities between pieces of data. I'm going again.